Okay, for this one we'll do 2.4 and 2.5 together. So for the first one, I have it. So P is the proposition I have a test today. Q is the proposition it is snowing, and R is the proposition I can drive to campus. I have a test today, but it is snowing, and I can't drive to campus. For the purposes of propositional logic, the word but basically means and. So I have a test today, so P, and it is snowing, and I can't drive to campus, so and not R. So that would be the way to express that as a logical statement. Now, to find the negation of the statement, I'll do this at the bottom. The negation of P and Q and not R, that would be, by De Morgan's laws, not P or not Q or not R. And that's the same thing as not P or not Q or R. Okay, so this would be in terms of just ordinary plain English. I don't have a test today. Or it is not snowing. Or I can drive to campus. Okay, so that would be the way to find the negation for this one. Okay, part 2, it is not snowing and I can drive to campus. So that would be not Q, it is not snowing, and I can drive to campus, not Q or R. To find the negation of this statement, this would be not Q, or not Q and R. That is equivalent to the negation of the first or the negation of the second. And by double negation, that's Q or not R. And so in plain English, this would be it is snowing or I can't drive to campus. So that would be the negation of the second statement. For the third statement, I will not have a test today if it is snowing. So this one would be if it is snowing, if Q, then I do not have a test today, not P. To find the negation of this, we have not Q implies not P. That's equivalent to not the first or the second. Then by De Morgan's laws, that's not the first and not the second, which is Q and P. So the negation would be, it is snowing, and I have a test today. Okay. The next one is I can't drive to campus even though it is not snowing. Now the even though basically is an and. So if we have it is an I can't drive to campus, so that's a not R. I can't drive to campus. And it is not snowing. So that's a not P. Or sorry, not Q. I got my letters mixed up. That's a not Q. So the negation would be okay, by De Morgan's laws, this would be not the first or not the second. And then by double negative, that's R or Q. So I can drive to campus, or it is snowing. Then finally, for the last one, I have to test today if and only if I can drive to campus. So this would be P if and only if R. Okay, so to convert that into, to find the negation, I have not P if and only if R. Okay, now finding the negation of this is going to take a little bit of work. This is saying not P implies R and R implies P. That both of those implications are correct. That's not going to be something shown in class. Okay, then I'll convert both of those implications into ORs. So not P or R and not R or P. Then by De Morgan's laws, that's not the first and not the second. Then by De Morgan's laws again, this will be not the first and not the second. Then I have this or carries. Then in here I have not the first and not the second. So taking the negation of this one separately, then taking the negation of this one separately. So that means P and not R, or R and not P. Okay, so I have two statements here. I have a test today. And I can't drive to campus. That's the first part. Or I don't have a test today. And I can drive to campus using the meanings of P and R. And I'm sorry, that got cut off at the edge there. I have a test today and I can't drive to campus, or I don't have a test today and I can drive to campus. So those are my two possibilities for this conclusion that I have here. And this is actually equivalent, and I wouldn't necessarily expect you to do this on the test, but this is actually equivalent to P if and only if not R. And I'll leave that as an exercise to verify that P if and only if not R is indeed the negation of P if and only if R.